Hey guys, I am moving back to swivel because I think it gives me a better picture quality and a bigger screen, as you guys can see. We're going to start this week with reviewing for our tests on Thursday. So we'll have a chapter 9 test from lessons 1 through 6 on Thursday. And so we'll be reviewing for a couple days. Today we're going to review actually the second half of the chapter, starting at 9-3b to 9-6. And I'm just going to go over a couple problems, and then you'll have a homework assignment at the end. But I'm going to start off with the dividing part of these kind of problems. So here you'll have 16 times the square root of g over the square root of 14. And just remember, if you have a square root on top and bottom, you can combine those or simplify those two. But if they're not both in the square root, you can't simplify this anymore. Okay, I can't simplify the square root of g anyway, and square root of 14 is as simple as possible. So in order to get our denominator to not be a radical, we're going to multiply the numerator and denominator by that square root of 14. And this is what I'm going to be left with. 16 times the square root of 14g. Because I can only multiply these two together, and that gets me square root of 14g over 14. Okay, but now that these two numbers neither of those numbers are inside the square root, 2 goes into that 8 times, 2 goes in that 7 times. So I end up getting 8 times the square root of 14g all over 7. And so that's my simplified form of that problem right there. So you'll get problems such as those. You also get problems that look a little bit more like this one, 27 square root of 27p over 6. So here, do you notice that the square root's over the whole fraction? So I can simplify these two technically. So I have 3 goes into both, here twice and here 9 times. So I'm really dealing with the square root of 9p over 2, which I can't simplify that anymore, and it really means the square root of 9p over the square root of 2. So again, just like with the last problem, I have a radical in the denominator, and I don't want that. So I'm going to multiply the numerator and denominator by that square root of 2, which is going to leave me with down here the square root of, and yeah, you can simplify that, but the square root of 18p over 2. And then if I can simplify anything, I'm going to go ahead and do that. 18 and 2 will not cancel each other out at all, so we're not going to try to cancel those out. But I know that this can be reduced to 3 times the square root of 2. So I'm going to be left with 3 times the square root of 2p over 2. And that's going to be my final answer right there. So it has to be in simplest form. I factored that into 9 and 2, and 9 becomes 3 outside, 2 gets left behind, and nothing else factors out. And then you sometimes get problems like this one right here. I'm going to look for one because they get a little more complicated, but something you should be able to handle. Square root of 10 minus the square root of 15 over the square root of 5. Okay, now it seems very tempting to just like cancel those two out or cancel those two out, but we're going to leave that alone for now. There is a way to actually cancel, but it's not just these two or those two. Okay, so here, if I want to get rid of the denominator being a radical, I'm going to multiply by the square root of 5 over the square root of 5. And again, there are other ways to do this, so this is not the only singular way of doing it, but here I end up with in the denominator with 5, which is very nice. That's what I wanted. And then I had 2 terms here, so I'm going to multiply using the distributive property. So these two multiplied give me the square root of 50, and then these two multiplied get me negative square root of 65. Okay, so I got that, but I know that these are probably factorable. So this one breaks down into 25 and 2. 25 and 2. So I end up with 5 root of 2. And if you want to check that, you can pause the video and see how I got that. And this one right here, thinking 5, 15, 20, no, 25. You know what? Wow. That's not 65. I believe it's 75. That makes more sense. So it's 75 right here. I multiply that wrong. But 75 is going to be 3 and 25. So I end up with minus 5 times the square root of 3 over 5. And this reminds me of the test. I actually gave you credit if you left it like this, but some of you were really good in determining, hey, these all have a 5 in them. So you were left with the square root of 2 minus the square root of 3, and that's it, because you factored out a 5 from the numerator. So I'm going to show you what that meant. You got 5 times the square root of 2 minus the square root of 3 over 5. And now these two can cancel out, and so you're left with that. I might give you like a bonus point if you can simplify all expressions. So I'd give you that on the test, but I'd give you a bonus point for that one. Just one little point for that, if you can simplify it completely. Okay, so you have those types of problems from 9-3b. And then let's look at 9-4. So if you're writing your notes, I'm going now to 9-4. And that lesson deals with the radical equations. So 9-4, for example, I'll give you maybe a tougher one. Yeah, this is a good one. 5 plus 3/4 times the square root of r plus 7 equals 8. Okay, so most of you did well on the test with this problem, but don't forget, you're trying to get the radical isolated, get by itself. It's being multiplied by 3/4 but added with 5. So I'm going to subtract 5 first from both sides. So I'm left with 3/4 times that radical. And then that gives me 3. Okay, so here you have a fraction being multiplied. You can multiply by its reciprocal. So you'll get 3 over 1 times 4 over 3. Well, that cancels those out. R plus 7 equals, and then thankfully that cancels out. I'm left with 4 if I multiply these two out. Then I'll square both sides, and I'll be left with r plus 7 equals 16. And then I will subtract 7 from both sides. R equals 9. Okay, but I always had to check it, which I saw a lot of you had a little check on it, which is great. Here's the original. Let's see if it works. All right, 9 plus 7 is 16. The square root of 16 is 4. 4 times 3/4 is 3. 3 plus 5 is 8. So that answer does check. So please check them. And yes, some of you did check and then you marked no solution, but for the most part, if you work it out and you check it, you're going to get it right, or for sure that you got it right. So please do so. Okay, then we go to 9-5, which is the Pythagorean Theorem. And the Pythagorean Theorem, as you guys remember, is going to be a squared plus b squared equals c squared. Now, as we get further into the curriculum, we're actually going to use the Pythagorean Theorem for other problem sets, and it's going to expand it more and more. So, this is the beginning of the Pythagorean Theorem, and then we're actually going to do problems that are more advanced, which are going to require a calculator for those types of problems. Okay, so here I'll get a right triangle. They'll give me 9 and 8, for example, and say find the missing side. So they'll find the missing side. So I have to determine, all right, C is either one of the legs or the hypotenuse. Now, technically in this problem, they didn't give me, I kind of gave it away, but they said find the missing side. This is all they gave me. And I'm thinking, all right, is this a leg or a hypotenuse? Well, it's across the right angle, so it's going to be the hypotenuse. So I'm going to set up 9 squared plus 8 squared equals c squared. So I know I'm looking for a hypotenuse. So that's 81 plus 64 equals c squared. I'm up here. I have 145 equals c squared. So I don't want, that's not my answer. It's not going to be 145. It's going to be the square root of 145. And then I have to realize, okay, can I simplify that? I'm going to see 5 goes into that twice, 9. Okay, so 5 and 29 Make sure that's 145. Okay, nothing goes into it, so that's going to be my final answer right here, the square root of 145. If you can simplify it though, you're going to go ahead and do that. That's going to be 9-5. Okay, and then the last lesson is going to deal with that distance formula, and that's coming from 9-6. So 9-6, and so that distance formula that you need to memorize is the square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. Okay, so that's the distance formula. And they will give you problems. I'm just going to pick one here. Okay, 5, -10. So they're going to give you 2 points. 5 and -10. And then -5 and +14. So they give you 2 points and they ask you, all right, what's the distance between these 2 points? So I'm going to put the numbers where they belong, and I'll start working it down here. So x sub 1 is 5. X sub 2 is -5. So instead of saying 5 minus -5, I say 5 plus 5 because that's adding the opposite. And then -10 minus 14. I'm going to leave it like that. -10 minus 14 squared. Okay. And then I'll keep simplifying that. 5 plus 5 is 10. So I have 10 squared plus -10 minus 14 is -24 squared. All right. So then I have to simplify these two. I get 100, and then 24 squared is 24 times 24. So we'll work this out. 16, 9, 0, 8, 4, 6, 7, 5, 576 plus 576. So I get square root of 676. Okay, but then I have to break that apart, and I'll do that here. 676, and I'm gonna go the easy route. 2, 3, 3, 8. I'll go 2 again. So I know it's gonna simplify because 2 goes into it twice. 1, 6, 9. Oh, and then that's a perfect square, right? So I take out a 2 and I take out a 13, and that's gonna give me 26. That's going to give me the distance between those two being 26. Okay, so that's how you use the distance formula on 9-6. So for your homework over this part that we just looked at, you're going to go back to that review section, and you're actually going to do, make sure I get these numbers right. You're going to do numbers 16 through 26. Numbers 16 to 26 even, and that's on page 239, 240, 239, 240. Okay, so you'll do those problems to review what we just went over, and then review on your own because we have a test on Thursday, and that will be the last part of chapter. We'll do Thursday, that'll be all of chapter 9, and then we'll get into the next chapter after you come back from your break. All right, guys, if you have questions, you can see me at 11:30, I believe, on today, and I'll help you out with that. All right, take care, guys. Bye.